Hello, iQuanters, presenting before you the iBrahma series of questions. Today, I'll be discussing a question which I posted on Facebook some days back. And the question is like this: in how many ways can four boys and four girls be seated so that no two girls sit together? Here, I haven't mentioned that what kind of arrangement is it. It can be linear as well as circular. So, I'll be discussing both the cases. So, first of all, let us discuss the linear cases. Now, it's known over here that the girls cannot be together. Now, that means the boys can be together. So, if you think that you have to arrange them in alternate positions, that will be a wrong judgment to make because the boys can actually sit together, but not the girls. So, let us do one thing. Let us assume four boys like this. I'm representing boys with B. So there are four boys like this, and there are 1, 2, 3, 4, and 5 vacant positions. All right. And in these 5 vacant positions, the girls have to be arranged. 4 girls have to be arranged. So now when I talk about arrangement, of course, we can use the factorials. So here there are 4 boys. I can arrange those 4 boys in factorial 4 ways. Because there are 4 boys, so the first boy has 4 spaces to choose from, second boy has 3 spaces to choose from, and so on. Now coming to the girls. So out of these 5 vacancies, vacant positions, vacant seats, I can choose 4 of them in 5C4 ways. So what is combination? 5C4 means choosing 4 out of 5. So by 5C4 ways, I have chosen the 4 spaces out of 5 vacant positions. And once I've chosen the 4 spaces, I want the girls to sit over there. So now we have 4 girls and they can sit there in factorial 4 ways again because therefore they can arrange themselves. So here, if I solve it, I get 24. 5C4 will be equal to 5 and then 24 again. So now if I solve this, 24 into 5 is 120, then 24 again. So I'll get 2880 ways. Hope this is clear. This is the mathematical approach. Now let us talk about an out-of-the-box approach, and that would actually be very interesting. So it happened with me that when I myself was preparing for CAT, at that time this question was asked to me by my teacher. So at that time I was not very, I was mathematically not that enlightened. Then what did I do? I thought in a very weird way that I think that will sound humorous to you, but now let's have a look at that. So I assumed that okay, 4 boys are sitting in factorial 4 ways. That is all right. I also understood that there are total of 5 spaces if I if I consider the first and the last one as well. So there are 5 spaces in which 4 girls have to sit. So at that time, I was not very well versed with permutations and combinations. So I used only basic logic. So what I assumed, the question says there are 4 girls. Okay. So what if I assume there are 5 girls and one of them is invisible? Yeah, that sounds humorous. I told this to teacher, he also laughed there. But now when I recall it back, I think that it was quite interesting. So I just want to share it with you as well. So I assume there are 5 girls, out of which one is invisible, one is ghost, chudel. So now I want to arrange 5 girls in 5 positions, out of which one is invisible. All right. So that can be done in factorial 5 ways, and that is our answer. All right, 24 multiplied by 120. That is the answer, 2880. Okay, do not use this always, that you always start assuming that girls are invisible, but that is just for the sake of humor and for a proper mathematical visualization. Hope you enjoyed this. Now coming to the circular arrangements. So if it is a circle and four boys and four girls have to be seated in such a way that no two girls sit together, so let us do one thing. 1, 2, 3, 4, 5, 6, 7, 8. Let these be the number of seats. There are 8 seats in total. So the first boy, if I assume that he sits over here, let me call him B1. All right? Let, him, let me call him B1. Okay, there's one thing. In the linear case, there was an extra space beside the last boy. But here in circular, everything is circle, so it comes back to where it started from. So of course there'll be no extra space. So the girls here would not be having 5 spaces. All right. So the only way left is to fix boys like this. There are 4 boys, and in respect to the first boy, the other 3 can be arranged. So, as you know, in circular cases, when there are n things to be arranged, the total number of arrangements is factorial of n minus 1. So there are 4 boys, so it will be factorial of 4 minus 1. And then we can arrange these girls anywhere. So that will be equal to factorial 4. Now, if I solve this, I'll get factorial 3 multiplied by factorial 4. 6 into 24 is 144 ways.